Jazz club, jazz atmosphere.
Hello. I can post the PowerPoint. That's a link to it, but I can also just post it on the website. Okay, so if you are here, go ahead and just say something in the chat. Jess, you're good because I know you're here. I just want to see if anybody else is here. All right, I'll just get started. So today I just wanted to go over a concept called recursion. which is something that people typically have a bit of an issue with. But once you understand it, it's not too hard to understand. And you'll, as you code more, you'll kind of like realize that sometimes like recursion is actually the better option than iteration. Recursion can always be used where iteration is used. And essentially the way recursion works is you have some sort of function, and maybe we pass in a number, and then you say if some condition, you return something, and then else you call the function again with some difference. And what these are called is, this is called the base case. So the base case is essentially the last case at which your recursive process terminates, and then the else will be the recursive case. And essentially this is all just, it really ends up working the same way as iteration, except the idea is that it's a function that calls itself. So it's kind of a weird thing to understand, but let's see if we can just like go through a few examples and it'll help illustrate the point. So let's say that we want to get the sum of all integers from 1 to n. There are a few different ways to do this, but we can do it iteratively and recursively. Recursively is going to be pretty easy. All you have to do is just say for num in range, and then just like 1 to number plus 1. And maybe we'll just have a, so we'll say sum is 0. And then we can say return, actually we don't even need a like a sum variable here, it's easier than that. We can just say return num plus some iterative num minus 1. So that would be the recursive case. So actually, no, it's not quite. No, sorry. Yeah, right. Okay. Sorry, we're doing it iteratively. I got confused for a second. I apologize. So we have sum is 0, and then we're just going to say sum plus equals num. So essentially, whatever num is right now, we're just going to add that to sum, and then we just return sum. So doing it iteratively is pretty easy. So all we have to do is just say print sum iterative, and then we'll say 100 to get the sum of all integers from 1 to 100, and it is 5050, which is correct. So doing that iteratively is pretty easy. Now the way you would do it recursively is you have to, and this is the way you really want to do everything recursive, you set up a base case and you set up an iterative case. And essentially the base case is where you stop. And in this case, we're going to stop when number is equal to 1, because we know if number is equal to 1, we just return 1. And that's when we stop. Like the sum of all integers from 1 to 1 does just happen to be 1. But for the recursive case, not iterative, the recursive case, we say else return number plus some recursive number minus 1. And a lot of times that'll be like kind of confusing the first time people see it, because you're really just talking about a function calling itself, which is already just kind of weird. But the idea is that we have some case where we essentially just terminate the whole process, and then some case where we just go ahead and like we call the function again. So in this case, what you want to do is you want to return whatever the current number is, plus, and then you just call the function again, and you just keep subtracting 1 from that number. And then when number is 1, you just return 1. So when we do sum recursive 100, I get rid of that. See what we get? We get 5050 again. So this actually still works, even though it looks a little bit different. Now, this would, you know, in a real life case, this would not be the time to use recursion, but that is an example of recursion, and it's a very easy, you know, it's a much easier example of recursion because you have this base case that terminates, and then you have the recursive case that actually goes through with the recursive process. So let's look at a couple more. So I just noticed that says iterative recursive. That's supposed to say factorial iterative. So the factorial of a number, you might see it as just like an exclamation point, is the product of all numbers from 1 to n. So 3 factorial is 1 times 2 times 3, which is 6, and then like you know, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. And this is something else. We can just have an iterative version of this, and we can also have a recursive version of this. It's going to look very similar to what sum is. So for iterative, we just have factorial product is equal to 0. So product is just the result of multiplying different numbers. And for num in range, so the same thing as last time, for num in range from 1 to number plus 1, we want to return factorial product times factorial no, sorry, I did it again. I keep trying to make the iterative functions recursive. Hello. So in this case, you actually need to start factorial product at 1, because if you multiply anything by 0, it turns into 0 again. And that's unfortunate. We don't want that. So we actually just say factorial product times equals, and then num. And then we will return num. Or return factorial product. So let's test that out. Print factorial iterative, and then let's get it 6 factorial. Let's see if we get the right answer. None. Huh, so I did something there. I'm not quite sure what I missed. That should be fine, as long as I called the right function. Well, that's interesting. For some reason, that function is not actually doing what I expect it to. Maybe try it like this. Still returning none. It shouldn't be, though. Oh, that's why. I accidentally have another implementation of the method down there. Yeah, it was actually because I already had a factorial iterative defined in this file, so it was actually calling the old one, so now it's going to work, yeah. So I had another factorial iterative just like defined down here, which is why that wasn't working. So yeah, I mean it's just the same logic as getting the sum. All you're doing is you're just iterating over a set of numbers from 1 to n, and then you're just getting the sum of those numbers. Now for factorial recursive, this one actually makes a bit, like honestly, factorial is the type of math function where doing it recursively actually makes more sense, because definitionally factorial is defined recursively, where it's defined as if n equals 1, it's 1, and if n is larger than 1, it's n times factorial n minus 1. So the actual definition of factorial is recursive in nature. So for this one, the base case is if number is equal to 1, return 1, else return number times factorial recursive number minus 1. So let's just test that one out. And unless I defined it somewhere else, we should get 720. Yep, awesome. So we were able to basically just define the same function in like 2 different ways. You can think of like recursion and iteration as a one-to-one operation in coding. Like you can, anytime you iterate it, you're iterating. You can also probably do it recursively. And sometimes doing it recursively will actually make the function a lot prettier. So in this case, this is a much, honestly, I think this is a much nicer looking function than this one. So you don't have to actually do the loops. But a recursive function is not going to have loops in it. So that's like one big difference. So let's look at Fibonacci. So Fibonacci is a sequence of numbers, just in case. So Fibonacci numbers are, it looks like this. You have 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 88, or 89, and you get the idea. So it's basically each number in the sequence is equal to, so f of n is equal to f of n minus 1 plus f of n minus 2. But the base case is f of 1 is equal to 1, f of 2 is equal to 1. So basically the first term in the Fibonacci sequence is 1, the second term in the Fibonacci sequence is 1, and then the each subsequent term in the Fibonacci sequence is the sum of the previous 2 terms. So you have like 1, 1, and then the sum of 1 and 1 is 2, sum of 1 and 2 is 3, sum of 2 and 3 is 5, sum of 3 and 5 is 8, and so on. So it's actually it's actually easier to define this recursively, although this is actually like a pretty like badly performing function in terms of like processing power and memory. But it's pretty easy just to do this recursively. So you just say if number is equal to 1, or number is equal to 2, return 1, else return Fibonacci recursive number minus 1 plus Fibonacci recursive number minus 2. So let's see how that works. Print Fibonacci recursive, and let's get the 10th number in the sequence. And it's 55, which I believe is correct. 3, 4, 5, 6, 7, yep. So the 10th term in the Fibonacci sequence is 10. Let's just go ahead and get the 40th term. Why not? And so you'll notice that like when we do that, it's actually still running, and it's taking a while for it to run because like if you actually think about kind of everything that's happening when it's trying to calculate that, it's it has to like spin off a bunch of subfunctions. So I'm kind of wondering like if it's even going to finish, because these kind of recursive functions actually balloon out of control really quickly. And this is actually a pretty good machine. So yeah, I think maybe don't wait. Yeah, the 20th term is 6765. And I'm kind of wondering where it gets slow. Yeah, so it'll start getting slower like pretty quickly once you get to like certain big numbers. So this is actually not a very performant function, but it's much nicer to look at this than it is to look at like what would be an iterative version. So to make something like an iterative version of Fibonacci, you would have to basically keep track of, you could basically keep a list of the numbers and just start off with 1 and 1. And then you would just say, you know, if number, or you could say while number is greater than 2, or while number is greater than Fibonacci list, the length of the list. You essentially just keep constructing the list until you have the number that you're looking for. So while number is greater than the length of Fibonacci list, you just say Fibonacci list dot append. So you put something at the end of the list, and it's just going to be okay. Well, you're gonna have to iterate through it. So it's just going to be, or it's going to be the last two terms. So the you could just say Fibonacci list, and then length of Fibonacci list minus 1 plus, and essentially what we're doing is we're grabbing the last two terms of the list. And then eventually number is not going to be greater than the length of Fibonacci list. So then you can just say return Fibonacci list, and then length of Fibonacci list minus 1. I think there's actually a better way to do that in Python. I think I'm going to do it like this. I think you can, if you just want to get the, or I don't know off the top of my head, I'll look it up. But let's make sure that this works the way we expect. We'll do 20. Neat. So it's still the same. And here's something interesting. So if we do the iterative version of this, it should actually be able to calculate it pretty quickly. Yeah. So like the Fibonacci recursive, like it was getting hung up on 40, and it was able to calculate Fibonacci iterative pretty much immediately. It's just a linear function. So the yeah. So, I mean, that's all it is. So basically, you just keep constructing the list until you have the number of terms equal to the number, like what you passed in to the function itself. There are also probably better ways to, I mean, there are definitely better ways to just do the Fibonacci function if you want to do that. This just happens to be like a really common interview question. So what you should know is just like don't give them the recursive version because that's not a performance one. So we're going to look at a few more things. So we have a function that is able to tell if a list of numbers is actually in the right order. So doing this iteratively is quite easy. All you have to do is just say for index in range, and then just say like 0 to length of list of numbers minus 1. So basically we're going to iterate through, we're going to check each value starting with the beginning of the list and then ending at the second to last, because the way we're going to be comparing is we're just going to say if list of numbers index is greater than list of numbers index plus 1. So essentially what we're going to be doing is we're always going to be comparing the current value with the next value in that list of numbers. And if it's greater, that means that we know that the list is not in order, so we'll just say return false. And actually, that's really it. And then at the end, we just return true. So all we have to do is we just say, like, if we're iterating through the list, if we look at something and the next term is actually great, if the next term is less than the current term, then we know that the list isn't in order, so we just return false. So do in order iterative, print in order iterative. I'll just make a list of numbers here. 1, 2, 3, 4, 5, and then I'll do another one that's not in order. I'll make this 10, so it won't be a part. So in order iterative list of number, and then we'll do it down here with the numbers not in order. And we'll see what we get. There we go, true, false. So we get a, so when we have a list of numbers that's in order, and we call in order iterative, we get true because the numbers are in order, and then we get false when the numbers are not in order. We pass a list where the numbers aren't in order. So let's take a look at in order recursive. So for this one, we're actually going to do this recursively, and it's probably going to look a little weird because essentially what we're going to be doing is we'll look at each value in the list and then keep passing a sublist. So we're going to keep slicing bits of the list down until the list just has one element in it, because a one element list is always going to be in order. So in this case, the base case is going to be if list of numbers, or if the length of list of numbers is less than or equal to 1, we return true, because that list is always going to be in order. Else, so now we have to keep checking stuff. So we can say, so if list of numbers 0, so if the 0th term, so like the essential like beginning term of the list, is greater than list of numbers 1, so the next term in the list, that's when we can return false, because we know that the list is no longer in order. So, but what we're going to end up doing is we're going to be passing a sublist back into in order recursive. To do that, we're just going to say return in order recursive, and then list of numbers, and then we can slice the list like this. We can say, or other way around, yeah, like that. So essentially we say pass in list of numbers back into the function, but start with the first term. So we essentially created a sublist. So we're not passing back in the whole list. We're just looking at starting with that term at index 1. So let's just make sure that this works the way we expect. We can just replace these. Cool, so it still works. True and false. So once again, just a different way of doing the same exact problem. In this case, in order iterative would probably make a bit more sense to use, but you know, it's always possible to do anything you could solve with iteration with recursion. And sometimes recursion actually ends up making more sense to use. Sometimes it makes less sense to use. It just kind of depends on the problem itself. And I'm going to look at one last problem. So for this one, we're going to look at a function that determines if a string is a palindrome. So for this one, you could do this iteratively and you can do this recursively. This is also a very popular interview question. This one comes up a lot, although usually with lots of caveats on it. But on a basic level, is palindrome. So basically a palindrome is just a word phrase spelled the same backwards or backwards and forwards. So you can reverse the the order of the letters and the term or word will be the same. Radar, race car, all those are palindromes. So to do this iteratively, there's a fairly easy way to do it, where you just go ahead and loop through. Well, actually, with Python, you can just do it really easily, because you can just reverse the string. So you can just say return string to test equals reversed, string to test. So I'm pretty sure that will just work. So word 1 is race car, word 2 is not race car. So we should get true, false here. Huh, oh, we didn't get it. Okay. This might actually just not work the way I think it does. That's okay, we'll actually just write it out iteratively. So for this one, the way you can solve it instead is just to have 2 pointers. So you have a pointer pointing at the end of the string and a pointer pointing at the front of the string. And they're each going to be different indexes. And then when the indexes cross, you know that you've actually checked everything. So, so we'll say pointer 1 is pointing at the length of string to test -1, and then pointer 2 is pointing at 0. Actually, it makes more sense to reverse those. So I'll make pointer 1 0, and pointer 2 the index that's just like right at the end of the array or the list. So while pointer 1 is less than pointer 2, if string to test pointer 1 does not equal string to test pointer 2, then you would just return false, because we know that those two things. So yeah, so like if whatever characters the 2 pointers are having you point at are not equal, then that means that this is not a palindrome, and we know it's not a palindrome, so we just return false. Else, pointer 1 goes up by 1, and then pointer 2 goes down by 1. And then essentially, like, this loop will just keep looping until we know that pointer 1 is greater than pointer 2, at which case, like, when they intersect, we know that every character that needs to be checked has, in fact, been checked. And we can return true at the end. So let's try running these again. Is palindrome iterative? There we go. So this one works. So it's basically saying that race car is indeed a palindrome, and that not race car is indeed not a palindrome. Now, it's actually a little bit easier in a way to do this recursively, because all we have to do is we just say, we don't really need the pointers. We just say, if string to test 0 is not equal to string to test length of string to test -1. So the last so we're comparing the beginning and the end of the string. So if they're not equal, we just return false. That's easy. And then else, we return. So we do need a base case. So I forgot to put in the base case here, where we actually return true, and we return true when the length of the string is 1, because essentially what we're going to be doing is we're going to keep passing a substring back, but the substring is just going to be the string itself with the beginning and ending character removed from the string. So what we can say is if string to test, if the length of string to test is less than or equal to 1, we return true. So that's the base case. And then the recursive case looks like this. So first we check to see if we would want to just say, like, this isn't a palindrome. We just looked at these two characters. We know that they're not right. So instead, if we look and we're like, oh, okay, they are the same, we want to pass the substring with the beginning and ending character removed. So we pass return is palindrome recursive, and then we do string to test, and we're going to be passing from 1 to the length of string to test minus 1. So essentially, we just want to cut the string. We want to cut the beginning and the last character, and this will do that for us. Also, I actually see that we get the length of the string a lot, so I'm just going to do that up here. strlen is equal to length of string to test, just because that's kind of ugly to keep having all over the code. So I'll replace those. Yeah, much better. Cool. So let's see if this works. True, false. There we go. So that one worked just by cutting off the beginning and end of the word and just making sure that what we cut off is equal. If they're not equal, we return false. And then if they are equal, then we actually just, we keep going until the length of that string is less than or equal to 1. So if it's a length 0 string, or it is a length 1 string. So anybody have any questions about that? I just wanted to go over recursion. It's at least good to see it once. Even if you never really end up using it or just see it in somebody else's code, that's fine. It's actually pretty rare that I end up using recursion. It does come up sometimes, though. Okay, so if nobody has any questions, I actually assigned a little project. This one should actually be like fairly challenging, but I gave you some code to start off with. Really, this is actually, so I did borrow this assignment from MIT open courses, but I did just like change some few things around so that it's more appropriate. But essentially what it has you do is create the Hangman game. So what I did was I put in some helper code on the website. And what you'll want to do is you'll want to make a directory, call it Hangman, something like that. And then inside the directory, you have the Hangman game, which will be here. And then you want to include a corpus. So corpus is just a list of words, comes up a lot in like machine learning. And this one's called words.txt. So you will want to download words.txt and then just have that in the same directory as Hangman. It's not letting me copy everything. That's okay. I'll just make it here. Well, that didn't work quite the way I expected it to. You should just be able to download this though. So, but if you can't, I might have to just let me see if it's in there. Yeah, here it is. It's in the class folder. So basically anything that I do, I try to put in here. I'll just make sure that they're all shareable. We'll make sure that this is shareable at least. Cool. Yeah, so all of these should be accessible, so let me just download this. Words.txt, you could actually just drag it right in there. Great, that's what we actually want. So we just want the actual full list of words here. And then hangman.py is basically some starter code. So you would have to read the directions and just like understand exactly what's going on. But I do encourage you to just kind of like read through it and try to actually get this done. This is a pretty cool project. It forces you to learn a lot of. It forces you to use. Forces you to use a lot of concepts that you would have seen in this class so far, and it's a really good way to just like get better at Python and then just like reinforce kind of like what you've already seen in class. I wanted to assign something that was a bit more like a bit more intense, just because I think that's really what kind of ends up like cementing a lot of concepts that you learn in a course environment. So, so yeah, like I just read the chat. Yeah, recursion is actually kind of like now I've done it enough where like it's kind of it doesn't feel all that complicated to me. But God, the first like, I remember like it took me a really long time to actually like fully feel like I understand recursion. But yeah, so if you think it's hard, that's fine. It is kind of hard. But I would encourage you to maybe do some coding bat problems that have to do with recursion, just to practice it. Because the only way you actually in my experience, the only way to actually understand the concept of recursion is just to practice it over and over again until you get it. I haven't figured out another way to do it. So if you know a better way to understand recursion, please let me know. And this was also like a pretty basic just overview of recursion. I just gave you like a real like just quick and dirty lesson on it because you can actually like, especially when you start thinking about stacks and then just like executing processes on a stack, they all end up getting processed recursively, and it gets really weird. So yeah, if it's hard to understand, that's fine. It's generally hard for everybody. So anyway, yeah, so just download hangman.py and words.txt, and you will want to read through the assignment. So the assignment I think should be pretty doable for everybody. All of the functions that you would need are all here. So they're all filled in, and there are doc strings that like basically tell you what each of the functions should do. And if you follow along with the assignment sheet, you will actually be able to like just say like, oh, okay, well, like let's do let's do this function, get guessed word, get available letters. It kind of like takes you through step by step and has you build everything like each module one by one. So I think it should be pretty fun to do. It's pretty fun to code games like Hangman when you're coding. So like I always really like just coding games like Sudoku or something like that, especially when I'm like trying out a new language. So anyway, I'd encourage that. That's actually all I have, just because I want to give people time to actually code, and a lot of people are having trouble keeping up with different lessons. So I wanted to keep this one short because I'd rather just give you time to actually work on the project, and then you can just ask me questions as you're working along with it. So feel free to just send me a message if you're working and you're getting stuck on something. I'm happy to help clarify or just work with you until you understand it. So does anybody have any questions about recursion or anything about the Hangman project? Cool. So it looks like everybody's good for today. So yeah, I don't want to inundate you with more information. I don't want to just keep going for. I don't want to just keep breaking your brain with recursion because it can definitely break your brain a little bit. But yeah, like get started on the project. It'll be a really good project for just cementing everything that you've learned so far. If you have any questions, send me a message and just let me know. And happy to help. You made Hangman and Flash like 15 years ago, so you're already an old hat at this. You'll be fine. So yeah, I figured you wouldn't have questions yet, but yeah, get started on the project and just send me a message if you have a problem, and I'll work with you guys. Anyway, see you later.